example, this section actually hasn't been too bad. I am relieved for both of us that we're able to get through this, I think, with relative ease. I do want to teach a little bit on definitions. In geometry, biconditional statements are used to write definitions. And basically, it's a true biconditional. And so if you can take a biconditional and the conditional statement is true and then the converse is true, then you've got a true biconditional statement. That's what we've worked on in the earlier parts of this. And so when we write a definition, they're writing a biconditional statement, but a lot of times they're not writing if and only if, they're implying it. And so let's say, like, for example, in your glossary, a polygon is defined as a closed plane figure formed by 3 or more line segments. Each segment intersects exactly 2 other segments only at their endpoints, and no 2 segments with a common endpoint are collinear. So you've got some pictures there. There's some pictures of polygons where you clearly see the closed plane figure. You've got 3 or more line segments depending on this particular shape. You see that they touch only at their endpoints, and no 2 segments with a common endpoint are collinear. So you can clearly see that you have polygons there, and then you have some figures there that are not polygons. They could be curved, or they could not touch at the endpoints, or they don't quite meet at the endpoints, or they crisscross. And you see that those are definitely polygons. There's even a 3-dimensional figure there that's not considered to be a polygon. Polygons are 2-dimensional figures. So another definition, triangle is defined as a 3-sided polygon. Quadrilateral is a 4-sided polygon. So what they're trying to kind of get you to understand is at the very bottom. A good, precise definition can be used forward and backwards. And this is how they do it. For example, if you're talking about a quadrilateral, this is how you can do it. If a figure is a quadrilateral, then it's a 4-sided polygon. If a figure is a 4-sided polygon, then it's a quadrilateral. It works forwards and backwards. It's true both ways. And to make our definitions very precise, it really does help to write them as biconditional statements first, because then you can see if it's true conditional statement and a true converse or not. And then you can write the definition. Okay, so what we're going to do is we're going to practice writing definitions as biconditional statements. And so here's our first example. A triangle is a 3-sided polygon. Okay, so don't overthink this, please. And I'm going to emulate the first one. A figure is a triangle if and only if I misspelled it. If and only if it's a 3-sided polygon. That's all I did there. I took exactly what they gave me, and I just inserted a couple of extra words. A figure is a triangle if and only if it's a 3-sided polygon. Okay? Because we also know that the reverse is true, but I'm going to write it in the order that they gave it to me. Because it does make sense that way, and it would make sense the other way as well. If a figure is a 3-sided polygon, or a figure is a 3-sided polygon, if a figure is a 3-sided polygon, then it's a triangle. So we can do the conditional statement and the converse, but I don't think that's necessary here. I think you can go right into writing the if and only if statement, the biconditional. I don't think you need to necessarily break it apart. All right, let's look at letter B. A segment bisector is a ray, segment, or line that divides a segment into 2 congruent segments. Okay, so kind of get the idea that here's our definition, segment bisector. It can be a ray, it can be a segment, it can be a line that divides another segment into 2 congruent segments. Okay, So let's back it up here. I really want to start here with my biconditional. I don't really want to start with a segment bisector. I want to kind of go even more simplistically than that. Array, segment, or line is a segment bisector if and only if it divides a segment into two congruent segments. So there you go. Okay, I did a little bit of rearranging, but it made sense to do it that way. I don't think starting with a segment bisector would have made sense. A segment bisector is array, segment, or line if and only if. I think it would be it makes more sense to say array, segment, or line is a segment bisector if and only if it divides a segment into two congruent segments. That makes a little bit more sense to me definition-wise. So let's practice with that. Let's kind of play with that. I'm going to give +1 for 4A and +1 for 4B. If you can rewrite those definitions as a biconditional and just do it as accurately as you can and you know, kind of talk it out. See if it makes sense to you. All right, if you have any questions, write those down and let's talk about them.